Okay, take your attendance first. Okay, class. So let's start our lesson today. Okay, I already passed this code to the in the WhatsApp, so you can check from there. Okay, so today, as I said, on Wednesdays we will be discussing the trial papers. Okay, so we explore from the bottom. Okay, so go back to that files. So this is the trial paper. I think the last week we discussed from the bottom the two papers, paper 1 and paper 2. So here I think you're supposed to do another 2 sets, right? The August 19 here, these two, paper 2 August 19 and paper 1 August 19 intake. And I hope you never stop there, you explore further. Okay, so first we go to the August 19, paper 2. This question, do you have any questions? Anybody?
3D.
3D. Oh, this is a moment. Okay, the weight of the beam is 12,000 Newton. Calculate the tension T1 and the T2 in the cable AC. Okay, so we go up to check the question. The weight of the beam is 12,000 Newton. The weight of the beam is 12,000 Newton. They want the tension or AB and AC. They want these two tension. Okay. Okay. So hold on. So they want the tension AB. So tension is acting up. Tension AB. For the rod, the tension is upwards. For the AC, also tension is up here. Tension AC. And the weight of the rod acting center, mg. Okay, now the question is, what you learned earlier? What you got earlier? You got state of what is explained, all just qualitative. So calculate the T1 and T2 in AB and AC. So two unknown. So you need to get two equations. Okay, first equation you can get it from the force. You can get first equation from the force, right? That's the easiest one. Two things equilibrium. Two things is conserved. Sorry, I will not say conserved. Two things. What is the two condition to be in equilibrium? What is the first condition? The net force must be 0, right? Net force 0. So from there you can get one equation, right? Force up equals to force down. So force up is what? TAB. TAB. Get the vertical component. TAB. TAB cos right, close the angle. So cos 53 plus TAC cos 37 should be equal to the force acting down, which is the weight. Weight how much? Weight is 12,000 Newton. So it should be 12,000. So 12,000 Newton. So one equation. Okay. Then the next, what you can do? I think net force you can get two equations, no, if you realize or not. But the other one is not really make sense. You can go for moment if you want. Moment. If you go moment, moment is little tricky, but you can go for horizontally. The force also balance horizontally. The TAB is exerting force to the left. TAC exerting the force to the right, to the left. AB is to the right, AC is to the left. Its component must be balanced. Okay, that means TAB sine 53 must be equals to TAC sine 37. Okay, I think in this case, by just using the net force is 0 vertically and horizontally, you can get two equations without going for moment. So two equations, two unknown, you can solve it. What's the mark scheme they put? Check the mark scheme. So T1 is 12 cos 53. T1 is 7,200 Newton. That's the answer. Oh, they use the triangle method. T1. Oh, they use only the force. Yeah. Also can. T2 is 12. So, oh yeah, they use the triangle method. This also can. This method also can. Okay, this method. This method is explaining in terms of what? In terms of the three forces acting. Because it's in equilibrium, mg acting down, TAB here makes an angle of inside 53. Okay, TAC should close the triangle because it's in equilibrium. Okay, but vertically here this is 37. Here 37. So if here 37, internally angle on top should be 37, right? Your maths, like zigzag 37. Okay, so here 53, here 37, 83, 90. So this should be 90 degrees. It's a 90 degrees triangle. So TAB here, TAC is here, and this is MG here. Okay, this MG. Okay, so MG, you know, is 12,000. From here, you can work out the TAC and TAB by using Trigo. Also can. This method also can. Okay. So how do you find TAB? TAB and 12,000, you use what? You can use 53. You can use cos or sine. Cos, right? Cos 53 is equals to adjacent over hypo. So TAB over 12,000. You can work out the TAB. Okay. And TAC, you can get it by using 53 also if you want. Sine 53, right? Use sine 53 opposite over hypo. So TAC over 12,000 also can get the answer for TAC. Okay, yeah. So this is one way, this is another way. This is simultaneous, quite longer. I think triangle looks easier. Any questions you don't understand?
Yeah, sir. Could you please explain the vector triangle again?
Vector triangle. How to plot them?
Yeah.
Okay. So to plot the vector, how to get the triangle is you need to have a skill. The thing is, what you do in exam, you scan the forces first. TAB, draw the TAB like thing like this, and that's an angle of vertically how much? 53. Okay, we draw them the vectors first. TAC was like this, and makes an angle vertically how much? Vertically 37. Okay, these are the two vectors. The third vector's weight, of course, is acting vertically down. Okay. Now these three arrows we need to join one after another to make a close triangle, close polygon actually, close triangle, three part. So my advice, first plug out all the vectors with its angle. The angle could be from vertically or from horizontally, from the diagram. Okay, now join one after another to make the triangle. Okay, what need to be draw first? Which one is need to be draw first? I prefer the one perfectly vertical or the perfectly horizontal to be used first. The diagonal connect the last. Remember, when you want to make a triangle, first go and draw the vectors which is perfectly vertical and horizontal first. Finally, diagonal. Okay. So here I prefer to draw MG first. First is MG. Okay. Second, any one of them will do because both are diagonal. So it doesn't matter. So I draw MG first, MG acting down. Okay. First vertical. And the tip, you'd have to make a triangle, close triangle, because it's in equilibrium for sure. So you can join the AB or AC one. Let's say you take AB, TAB will be here. This is a TAB. Check the angle. Vertically, it makes 53. So here, vertically should be 53. See, this is 53. Vertically is 53. 53. Again, TAC, this, put it as the last. So it can be like this, TAC. And it makes an angle vertically 37. So if I draw vertical here it makes 37. So maths, do you learn, right? Like zigzag here is 37. Here also should be 37, right? If these two parallel. So inside the triangle, it should be 37. This MG. So 53, 37, this makes 90. So that's it. This is one way of doing. Okay. Or you draw the MG first. Connect TAC. TAC is here. Inside here, it's going to be 37. Then finally, AB here. TAB vertically makes 53. So internal going to be 53. Here going to be 90. Still the same. This is another triangle. You get the same answer. Okay, my advice, get all the three vectors with its angle. Either the angle must be from vertical or horizontal. Start to draw the triangle by using the vector with perfectly vertical and horizontal first. Okay, you've got one vertical, another one horizontal, another one diagonal. Best is take the vertical first, draw the first one, then draw the diagonal, the horizontal one, then finally you take the diagonal to make the triangle. Any part still don't understand? Anybody? Okay. So no questions. So I assume you understand. Okay. So that's what to get and say 4 marks. Quite a lot. Okay. Any other questions?
Sir, 3C?
Yeah. 2C.
3C.
3C. Yeah. Oh, this is DC. Explain why the center of gravity of the beam must be vertically below A. Yeah, correct, right? So that the resultant moment is 0. The resultant moment is 0 because if you have any uneven object, okay, you tight with the string here, okay. When it comes to equilibrium, the center of gravity must be below the pivot, because center of gravity is a point where the whole weight of the object is considered to act. Okay, so the question explain why the center of gravity of the beam must vertically below A, because you have to say center of gravity is a point where the whole weight of the body is considered to act. So the center of gravity have to be below the pivot so that perpendicular distance is 0. Because what is moment? Moment is the force times perpendicular distance, right? Perpendicular distance from the pivot. If you can't have like a body balance, this is the point where you tighten it, and you can't expect it going to be in equilibrium. The CG is here, okay, because this never happens in nature, right? The center it become equilibrium when the center of gravity is not below the what you call the pivoted point. Why? Because the center of gravity is here. It has a perpendicular distance. So there is a perpendicular distance. If it has a perpendicular distance, there will be a moment. So if there is a moment, resultant moment, then it's not in equilibrium. So to be in equilibrium, the net moment must be 0. For the net moment to make it 0, the center of gravity have to be below pivot. Why? The whole weight of the object is x at the center. Okay. So no perpendicular distance. That's the main thing. Okay. So there is no resultant moment. Yeah, no resultant moment. So does not rotate, oscillate, swings. So because A is the pivot. Yeah. So there is no resultant moment because no perpendicular distance. So that's 1 mark, right? What's the marks given? So there is not resultant moment, 1 mark. Moment do not balance. Oh, this all are 1 mark. Above the pivot. Oh, above the pivot given 1 mark. So there is no net moment. That's the reason. Okay. Riyad, you got idea?
Yeah, sir. Thanks.
So always go to the two condition to be in equilibrium. Resting, net force always 0, but resultant moment also must be 0. To have a resultant moment, the force should not have a perpendicular distance from the pivot. Only achieve when the CG is below the pivot vertically. Any other questions? This paper? Normally, as I said, mark scheme should be quite helpful. Okay. So if you don't have, we can go to the paper 1. No questions, Okay. So let's we go to the next paper. Okay. Okay. So we go to the next paper, The next paper is the paper 1 here. So you go to the paper 1. Yeah, this is the paper, right? The paper 1, August 20. Any questions from this paper?
Question 7.
Question 7. Okay, we go to question 7. Okay. Hold on. Sorry. Let me check. Did I record it? Oh, recording. Okay. Okay. Question 7. Kinematic graphs. Okay. A stone is thrown upwards from the top of a cliff. After reaching its maximum height, it falls past the cliff top and into the sea. Okay. So you have to. So there is a cliff. There is a cliff. There is a river of sea here. So they throw the stone upwards and you go to the top of the cliff. From the top of the cliff, after reaching a maximum height, it falls into the sea. Okay, this is the diagram. Okay, so it goes up and fall into the sea. It's a cliff. Okay, so what is the maximum height above the sea that the stone can reach? What is the maximum height above the sea? Above the sea, above the sea, above the sea that the stone can reach. That means from where to where they want the distance. Maximum height above the sea. They want from here, from relative to the sea, what is the maximum height you can reach? So this is your maximum height. They're looking for this value, right? Okay. So this value is actually what? What is area of S? Area of S is this is your area of S, right? The distance, the displacement going up, because the velocity decreased to 0. Yes, velocity 0. Here is where it achieved the maximum height, right? Maximum height, correct? So this S is the area to go up. R is what? R is the total displacement and going down, right? So R, the answer should be R. What is the maximum height above the sea that the stone can reach? What is the maximum height above the sea? They want above the sea. So it should be R. Okay, Ashley, you got the idea?
Yeah.
Okay. Any other questions? Okay, take down first the others if you got any problem. Okay, any other questions?
8.
8. Okay, so we go to 8. Okay, 8. A free falling object on Earth at speed of 5 meters per second. A free falling object on Earth has a speed of 5 meters per second. After falling a further 20 meters, its speed is, it's a free fall, right? So whenever you see the word free fall, that means no air resistance. So acceleration is the gravity. So it's 9.81. So A we know. So A is 9.81, and the velocity at that moment, that means U is 5 meters per second. The initial velocity 5 meters per second. At the moment it traveling, the U is 5 meters per second. Okay, then they say after falling a further distance, that means it already fall for a distance of 20 meter. That means after S is 20 meter, U is 5, S is 20. What do you want? What is its speed? That means they're asking for the final speed. So U, S, acceleration, is 9.81 meter per second. Okay. In this case, we take downwards as positive, let's say. So we take A is 9.81. Find V. So what formula do you use? V squared equals to U squared plus 2AS, right? Without time. No time not given. So we can't find. So work up. So V squared equals to U squared plus 2AS. U squared is 5 squared plus 2, 9.81. S is 20 meter. Square root this value, you get your V in meter per second. Right? So it's kinematics. One of the kinematic equation to be used. Three data is enough. So you know U, you know S, you know A, find the V. This is how do you summarize the question, right? This is the summarization. How do you summarize it? By drawing. Okay, so what do you get by applying this? 5 squared plus 2 times 9.81 times 20. 20, yeah. Okay, so you get 20. The answer given is 20?
Yeah.
Okay. Okay, please take down before we go to the next one. Let's give you 1 minute.
Sir, can you explain 36?
36, okay. Let's keep for a while. So already take down now. So we go to 36. Okay, 36. A cell of electricity, cell of internal resistance is 0.5 ohm. Is connected to a fixed resistor of 10 ohm. The resistance of the resistor is changed to 20 ohm. Which statement is not correct? Okay. So originally the battery was as an internal resistance of 0.5 ohm. It has a 0.5 ohm internal resistance. The load was at the beginning was only 10 ohm. That means the capital R, the load is 10 ohm. 0.5 small r, and voltage, we assume it has a certain EMF E. They didn't give the E. Okay. So how this linked E equals to I small r plus I capital R plus I small r, right? Based on Kirchhoff second law. So I capital R should be your terminal PD. This is your terminal PD. Okay. Okay, so let's see. Which statement is not correct? If the 10 ohm was replaced with 20 ohm, that means capital R has been increased. If the capital R increase, what are the effects? That's the answer. Okay, the first one. If you increase the capital R, what will happen? First, the current in the circuit will off. Oh, current in the circuit, is it off? Current is what? I equals to total EMF E over the total resistance. Last time was 10.5. Now is 20.5. Is it aft? The new current? I think the new current, when it become aft, it's become 21, right? This is 10.5, this is 20.5. Right? So not quite close, but not exactly aft. Not exactly aft. Okay, so which statement is not correct? A looks like not correct, but it's quite close to half actually. 10.5 is the total resistance at the beginning. It become E over 20.5, total resistance 20.5. Actually, when the current become half, when the resistance is 21, right? 2 times over 10.5. 21, yes, half. But let's check. We go for the best answer. So A, not really. B, the EMF of the cell will remain constant. Yes, this is correct. EMF, the two quantity which unaffected by for A levels, for A levels, for a new battery, for a new battery, EMF and its internal resistance is always constant. Okay, remember, never change. EMF and the internal resistance of a battery cannot be changed by the external, changing the external load. Increasing the external load or decreasing the external load only can change the current flow, change the power dissipation. Never change the EMF, never change the internal resistance. So B is correct. EMF of the cell will remain constant, never change. Okay. See, the power dissipated by the fixed resistor will decrease. The power dissipated by the fixed resistor will decrease. Oh, the power in the external load. Fixed resistor is the external load, right? Okay, 10 ohm change to 20 ohm. What happened to the power in the external load? How to find this power dissipation? Power got three formula: IV, I squared R, V squared over R. Okay, the first case, case one, we know R is 10 ohm. Case 2, we know the R turned to become 20 ohm. Okay. Do you know another two, either V or I? Do you know for the both cases? We don't know the. Maybe we can get the V. I think V we can. V is possible. For the first case, can you get the V? Second case, can you get the V? In terms of EMF, I think the best formula we can find the power is V squared over R. I think V squared over R. Okay, should help us to find the value. Okay, so for the first case, case 1, what is the V used up by the 10 ohm? First case, this is 10 ohm, 0.5 ohm. 10 ohm, 0.5 ohm share the E, right? We put a E. So 10 ohm take how many E? So what are you going to put here? The ratio, right? 10, 0.5 share the E, EMF E. So 10 take how much? 10 over the total resistance, right? 10 over 10.5 times E is the voltage, right? 10 over 10.5 E. There's the voltage for the first case utilized across the fixed resistor. Okay. So first case we know R and V. V we know in terms of E lah. Okay. Second case, when R is 20 ohm, V will be how much? What is the V? 20 over 20.5 E, correct? Yeah, correct. So this is the two reading, right? Okay. So now let's compare the power. We want to compare the power. What is the power one? The first case power. VR we know, so we use V squared over R. So what happened? It's going to be 10 over 10.5. 10.5. What is that? Squared E over 10, right? Okay. The second power is what? Second power, V squared. Here V squared is 20 over 20.5 squared E over, what is the resistance? 20. Oh, lots of work, eh? Okay, can you tell me this power is how many E? How much you get? 10 squared over 10.5, eh? What do you get? It's 10 squared over 10.5 squared. Anyone can calculate for me? 10 over 10.5, square it, then divide by 10. What do you get?
0.091.
0.091 E. Okay, so the power dissipated in the first one is 0.091. For the second one, 20 over 20.5 squared, divide by 20. How many you get?
0.0476.
0.047. So this shows power drops. Okay, power drops. When resistance increase, the power drops. So the power dissipated by the fixed resistor will decrease or drops. So this is correct. See, looks correct. Oh, okay. And third, the terminal PD of the cell will increase or decrease. Terminal PD. Terminal PD is very easy, right? 10 ohm, terminal PD is already calculated here. You see, the V here is the terminal PD, the V we calculated here is the terminal PD. For the case 1, what is the terminal PD? 10 over 10.5 E. Case 2, what is the terminal PD? 20 over 20.5 E. Which terminal PD is greater? Case 2 is greater, right? When the external load resistance get big, the terminal PD get big. Okay, that's a ratio of resistance one. The load get big, resistance means it will take more voltage. So terminal PD get big. Okay, so D, the terminal PD of the cell will increase. Yes, correct. So answer is A. Answer given A. Anybody? What's the answer given for 36? Is it A? Sensor. So 36A, yeah, it's A, So correct, it's A. Good question. Lots of work. Okay. So I think the first, I hope you understand all the reasoning. A is not exactly off. This is the reasoning. This how to calculate it. Not perfectly off. The EMF of the cell will remain constant. It's a fact to remember. B is a fact you need to remember. E and internal resistance of a battery never ever change. Okay. For A levels now, I said for a new battery. Your A levels always new battery. Of course, in reality, practically, if you use a battery after 1 year or maybe a phone battery or something, the EMF will drop slightly. But A level EMF is constant. New battery. So C, the power dissipated fixed resistor will decrease. The C for reasoning out takes the very long understanding. This is the reasoning for power. So you need to find resistance, you know, voltage ratio looks like 20, voltage get bigger, but the ratio looks like power drops. Okay, external load resistance increases, the power drops. Okay, power drops, yeah. And the fourth one, the terminal PD of the cell will increase. When the external load increases, terminal PD confirm increases. Okay. So therefore answer is A. Okay, guys, any part you don't understand? Good question. 36. In a real examination out of 40, I think 3 or 4 questions will come to like this level. Like you really need to do a critical thinking. Might drain your time. Okay, so you have to be careful. If you feel that it's difficult, just skip the question first, do the easiest one first, then second round come back again to do these questions. Okay. Okay, 1 minute for you to take down. Or any questions?
Sir.
Yeah.
Can I explain about D? Why does it increase?
Terminal PD.
Yeah.
Why terminal PD increases? Because I go to this. Okay. Okay, why terminal PD increases? You see, you can put numbers. Let's say internal resistance, let's say 1 ohm is the battery. External resistance, let's say the load, you put 2 ohm. So terminal PD, the terminal PD is the voltage. Yeah, it's actually voltage across this external load. E equals to IR plus I small r. This is your terminal PD. So if you use Kirchhoff law, the EMF is shared by two resistance, the 1 ohm, the internal resistance, and the 2 ohm in this case. So how much of fraction of EMF will be used up by 2 ohm? It's ratio. So 2 over the total resistance, 3 E. So for this case, the terminal PD will be 2/3 E. It's the terminal PD, 2/3 E. Okay. Okay, now this R, capital R, you increase it. Let's say you make not 2 ohm, you make it, let's say 4 ohm. So what is the new terminal PD now? 4 and 1 shares the E shared by 1 ohm internal resistance. The capital R become 4 ohm. So you see, big resistance take big voltage. So how much is the voltage now? 4 divided by the total resistance by E. So 5E is the terminal PD.
All right, got it. Thank you, sir.
Okay. Okay, so that's the question 36. Any other questions?
37.
37. Okay, good. We go to the 37. Okay, 37. Minimize it. Okay. So there is a circuit given. A cell electromotive E and internal resistance is connected to a network of resistor of R1, R2, R3, and R4 shown. Okay. The branches of the circuit have current I1, I2, I3. Or the main current is I1 split into I2 and I3. Okay. I2 got R2, I3 got R3 and R4. Okay. Okay. Which equation is correct? Okay, so this is a question Kirchhoff law. Kirchhoff first law, Kirchhoff second law. Okay, so Kirchhoff first law is what? Current flow into the junction equals to current leave the junction. Current flow into the junction is I1 equals to I2, I3 that we know. But looks like all the equations here looks like Kirchhoff second law. But first law, what you got? First law, I1 should be equals to I2 plus I3, correct? You take this junction, current flow into the junction is I1. Leave the junction is these two, I2 and I3. Okay. But okay, this one equation. Okay, next. Which equation is correct? I1 R1 plus I2 R2. I1 R1 plus I2 R2. I1 R1 is what? I1 R, oh, this one. I1 R1, this PD here, plus I2 R2. I2 R2. Is I3 R3 plus, okay. Okay, before we go to the answer, let's reduce Kirchhoff's second law. Let's say we take the first loop. There are how many loops here? 3 loops. Okay, this is the first loop. This is the second loop, and the third loop is the outer one. Okay, let's make equation for the first loop. Just use first loop, and this is your first loop. Okay, for the first loop, write the Kirchhoff's second law. Sum of EMF equals to the sum of PD in that loop, right? So first step, what do you do? Choose the direction. So in this case, we follow the battery direction. So we go which direction? We go anti-clockwise. Anti-clockwise, what is the total EMF for the first loop? EMF E is the total EMF. How many PD are there? 2 PD. The R1 is 1 PD. What is the PD of R1? I1 R1 plus, and come down here, the PD here is I2 R2. Okay, this is the equation for the first loop. First loop. Okay, we go to the second loop now. Second loop is the outer one. Okay. Oh, the third loop is useless actually. So we go to this is the second loop. We go to the outer one. Okay, outer one. E equals to what? Third loop, from this. Okay. We go to the outer one. Okay. So total EMF is what? E. So it's E equals to how many PD are there for outer loop? Here 1 R1, here 2 R2, here 3 R3. Got 3 PD. 3 PD. So E equals to I1 R1 plus, come here, I3 R3, right? Yeah. I3 R3 plus, this is what? I3 R4. I3 R4. This is the equation for the outer loop. Kirchhoff's second law. Sum of EMF equals sum of PD. Okay, now we check. Is it A correct? I1 plus I1 R1 I2 R2. The first loop, I1 R1 plus I2 R2 is equals to E. But E equals to what? I1 R1 I3 R3 I3 R4. So wrong, right? This is wrong. Should have I1 R1 here. Here also should have plus I1 R1. Then correct. But you don't have that. So A is wrong. Right? So B. I2 R2 I3 R4. I2 R2 is what? Oh, I2 R2 here. I2 R2. Yeah. Do you know this is parallel? These two parallel. Okay. I2 R2 is actually same as the voltage at the bottom here. I3 R3 plus I3 R4. Okay. Do you agree? Do you agree with this? See, the volt PD here should be same as the PD here because they are parallel from this branch. So I2 R2 is the same as I3 R3, I3 R4. Based on this, can we make this? I2, if you bring all to one side, it's going to be I2 R2 minus I3 R3 minus I3 R4. I3 R3 minus I3 R4. This is correct. Yeah, B correct. Because parallel, the potential must be same. Okay. Other than that, I2 R2, this is we know it's E. It's wrong. This is wrong. E is actually this two. I2 R1, I1 R1, I2 R2 is E. Here I1 R1 plus I2 R2 plus further it's not E. So C wrong. D I1 R1 I2 R2 is already E. Minus with something, this cannot be E. So B is the answer. Kirchhoff's second law. Okay, which part still don't understand? Anybody? Okay, please take down. Try to. This is basically Kirchhoff's second law. First law also never really applicable. Okay, take down first before we go to the next one. Okay, any part you don't understand about the circuit, you tell me. I give you 1 minute to take down before we go to the next question. Okay. I think it's recorded, right? So you can view, right? Okay, next question.
38.
38, Okay, 38. Okay. Okay, again, circuit. The circuit shown consists of two resistors of resistance 10 kilo ohm, 50 kilo ohm, or 10 and 50, and component Y. Oh, there is another load here which has some resistance. We don't know how much. 6-volt supply is provided. The electric potential of the bottom wire is 0. Oh, so the 6-volt is applied. The current in the component Y is negligible. Oh, if the current is not flowing in the component Y means, that means component Y has a infinite resistance or zero resistance. What do you think? You see, there is neglect the current flow into the component Y. If they neglect it means the current flow to the component Y is about close to zero. That means component Y has a infinite resistance or zero resistance. It should be infinite, right? It should be an infinite resistance. That's why current flows here, not even much current flow into the component Y because very big resistance. It's like voltmeter. Okay, can be like a voltmeter. Voltmeter has an infinite resistance. Okay, so when I read this statement, so what you should conclude, component Y is a very high resistance. Okay, so what is the electric potential at junction X? Oh, see, this is 50 kilo ohm. This we know is as infinite resistance. Okay, so 50 kilo ohm, infinite resistance. Effective resistance how much in parallel? Effective resistance of parallel how much? 50 kilo ohm or infinite ohm in parallel how much? So 1 over 50 plus 1 over infinite reciprocal, you get the effective resistance. 1 over infinite is 0, right? 1 over 50, 1 over infinite is close to 0. So the effective resistance is actually 50 kilo ohm. 50 kilo ohm. I mean, this circuit, we can imagine like top got 10 kilo ohm. Bottom also the effective resistance is 50 kilo ohm. The component infinite resistance never affect the total resistance of the bottom part. Okay, so those who understand the component as the negligible current flow, it has infinite resistance, so effective resistance still 50 kilo ohm. So they're asking up is 6 volt, down is 0 volt. They're asking what is the potential at junction X. What is the V here? So I have to know. So voltage here, check the voltage at X is actually the voltage of the 50 kilo ohm now. Okay. 50 kilo ohm and 10 kilo ohm take how many volt? What is the potential difference? 6 volt, right? 6 minus 0, 6 volt. 6 volt is shared by who? Shared by 10 kilo ohm and 50 kilo ohm. Okay. What is the voltage used up by 10 kilo ohm? So ratio, right? 10 kilo ohms, 50 kilo ohm take 6 volt. 10 kilo ohm take how much? So ratio, right? 10 divided by 60 times 6. So 1 volt. So 10 kilo ohm, you each 1 volt. It used up 1 volt. That means here positive 6 volt after crosses the X become 5 volt. It's called 5 volt. Okay, so the voltage at X will be 5 volt. Will be 5 volt. Instead, you calculating the voltage up, you better calculate the voltage down. Easier. The voltage at X is actually the voltage at the voltage used up by the bottom resistance. So you do 50 over 60 times 50 over 60 times 6, you get 5 volt. So voltage above is 5 volt. Okay. So what you learn something new here is when they say current flow is negligible, that means that component has an infinite resistance. So effective resistance of the parallel will be still the same as 50 kilo ohm. Okay. So then you use a ratio to calculate what is the voltage used up by 50 kilo ohm. Then you can find the voltage at X. Okay. Any part still you don't understand?
I get it now.
Get it now, huh? Okay. Others, any questions about this part? Okay, again, take down before we go to the next one.
Sir, can go to 9.
Question 9, okay. Okay, I hope you can check video, 9. Okay, question 9, projectile movement. Projectile, okay. A projectile is launched at point O and follows a path. Okay, OPQRS as shown. Air resistance may be neglected. Which statement is true for the projectile when it is at the highest point Q of its path? Or what is true at the top? So which is true? So 3 wrong, 1 correct. So we are looking for the correct one. The horizontal component of the projectile acceleration is 0. Correct, right? Is correct. Correct one. Because do you know when I teach projectile vertical, horizontal, the first thing you can write the information is AY is negative 9.81, AX is 0. For any point, AX is always 0 at any point, AY is negative 9.81. The vertical acceleration, horizontal acceleration is always constant, fixed. So the horizontal component of the projectile acceleration, so they are talking about AX here. It's always 0, yes, correct. A is correct. Okay. So B, the horizontal component of the projectile velocity is 0. So horizontal component of the projectile velocity. The B, they're talking about the Vx. The Vx. Vx, is it 0? B is horizontal component. This is your U, you get UX and UY. Okay, after you launched, you get V and VX, VY. The UX, UVX is always same one. The horizontal component is always same, right? So VX is constant, but not zero, not necessarily zero. It has a value. It can have value. If you launch with 30 meter per second, makes an angle of 30 degrees. The horizontal component is 30 cos 30. It has a value. So not zero, not necessarily zero. If horizontal velocity is zero means it's not a projectile anymore. It just goes straight up and come down. So B is wrong. Okay. See, the vertical component of the projectile acceleration is zero. Vertical component is your AY. AY is always negative 9.81, taking upwards as positive. So this is wrong. 30 is AY. AY we know is negative 9.81, taking upwards as positive. So it's not zero. The vertical component of the projectile displacement is zero. Vertical component of the projectile. Vertical component changing with time. But every moment has a different vertical displacement. So it's changing. It's not zero. The vertical component of the no, that's a value. So it's wrong. So A is answer. Okay. Any questions? Anyone got the idea? So any problems still? So A is answer. Okay. Any other questions? The one asked, able to understand? Can Okay. Any other questions, guys? Anything still you don't understand about this?
Question 23.
23. Oh, this one. 23. Diffraction can be observed when a wave passed obstruction. The diffraction effect is greatest when the wavelength and the obstruction are similar in size. Yeah. The best diffraction happens when the gap, right? Okay, best diffraction happens when the size of the gap is about same as the wavelength, right? Wavelength. Okay. Okay. So for wave traveling through air, what is the combination of wave obstruction that could demonstrate the diffraction? Okay. So you need to show that for which pair the wavelength is about same as the gap, about the gap. Okay, or let's say you have obstacle, obstacle, something, a block. When water passes the obstacle, diffraction also happens. In this case also the size or the gap should be A. The gap should be A. Okay, so first case, microwave passing a steel post. Okay, so microwave passing a steel post. Steel post is around what is the thickness of the steel pole? It's 10 centimeter. 10 centimeter. Guys, just hold on. Just give me a minute. Sorry, just 1 minute. Hold on. Okay, guys, sorry. Okay, so let's we discuss back. 23. Okay, so as I said, the wavelength and the gap must be about like, so still post, I think it's around 10 centimeter. Maybe around 10 centimeter, the post. Okay, so microwave, do you know the wavelength of the microwave? So you have to know the wavelength of the microwave. What is the wavelength of all the EM radiation? So recall back. So gamma start with what? Is 10 power of negative 12 meter, negative 10, negative 8, visible is negative 7, infrared negative 3, negative 2, 0. So here microwave is found to be negative 12, negative 2, sorry, negative 2 meter. Negative 2 meter is how much? Is 0.01 meter, 0.01 meter. It's like 1 centimeter. Microwave is like wavelength is 1 centimeter. The still post is 10 centimeter. The A is 10 centimeter. The lambda is 1 centimeter. Okay. But we want the best diffraction when lambda is about same as A. So we check the pair which quite close to each other. Lambda and A must be the same. We go for the second one. The first one is 1 centimeter with 10 centimeter. Okay. Second one, radio wave with copper wire. Copper wire is in is millimeter, right? The diameter copper wire. Maybe take, let's say, 1 millimeter. Radio wave is how much? Radio wave is 10 power of 0. Can go like 1 meter. I go for 1 meter. Radio wave wavelength, let's say, is 1 meter. Because 10 power of 0. 10 power of 0 meter is like 1 meter. The copper wire is 1 millimeter. Okay. This is maybe the meter I changed to millimeter. So 1 meter, how many millimeter is 1000 millimeter? 1000 millimeter, 1 millimeter. Okay. Third one. So I think A looks better than B. Quite close. 1 centimeter, 10 centimeter. B is 1000 millimeter the wavelength. This is only 1 millimeter. Okay. C, sound wave passing a human air. Sound wave, what is the speed of sound wave? Sorry, the wavelength of sound wave. Sound wave can go few meters now if you want. Like V goes to F lambda. Speed of sound wave, let's say 300. Frequency, let's say, is 10,000 hertz. You can find the wavelength. Wavelength. How much the wavelength you get? 300 over 10,000. 300 over 10,000. Cut is 0.03 meter. Human hair is few micrometer. Let's say this 1 micrometer. Human hair is in micrometer. 500 micrometer. The sound wave is like 3 centimeter. 0.03 meter is like 3 centimeter. 3 centimeter, 1 micrometer, big difference too. Sound wave pass through the human hair. Visible light passing a gate post. Or gate post. Visible light is 10 power of negative 7 meter. Gate post is quite in centimeter. Okay. So I think this also quite big. Negative 7 meter, 1 centimeter. 3 centimeter, 1 micrometer. 1000 millimeter, 1 millimeter. 1 centimeter, 10 centimeter. So which is like lambda is about same as A. I think I go for A. What's the answer given? Anybody? It's given is B. The answer given is 23. Yeah, A. It's A. So yeah, A reasonable because the differences is not that you see. The best diffraction happens when the size of the obstacle or the gap, the A, must be about same as lambda. You have the best diffraction with the greatest intensity. It spreads more at the same time you have a reasonable intensity. That only happens when lambda is about same as A. So you have to check, calculate the lambda and A for both, check which is quite close to each other. So A found to be Microwave 1 cm, the still post estimation around 10 centimeter. So both are cm. The others look further apart, not that close. So A could be the best answer. So microwave wavelength, you have to use this to calculate your microwave wavelength. You have to know. Okay, very good question, but you have to do kind of estimating the values. Okay, you have to know that steel post is in like around 10 or 20 centimeters. You have to know the copper wire is like in a millimeter range. You must know human hair is in micrometer range estimation. Gate post also is in few centimeters. Yeah, then you can do a better estimation. Any questions? No, anyone don't understand any part from this 23? No questions. So you hope everyone understand. Very important. Remember this. Memorize this by heart. Okay, the wavelength and of course frequency of it. Any other questions?
20.
20. Okay, so we go to 20. Okay, 20 moment. Okay, along a uniform beam pivoted at one end, a force 300 Newton is applied here on the right. It's applied to hold the beam horizontally, or the beam is horizontal. It's in equilibrium. What is the mass of the beam? Because they said it's uniform, because they say the word uniform, that means the weight of the beam is acting at the center of the beam, and the weight mg acting at the center. They say uniform. So what is the mass of the beam? So they're asking what is m. M we can get if you know the weight. How to calculate the weight? We use moment. So we take moment about a pivot. Pivot given, take moment about the pivot. So moment about the pivot. Take moment about a pivot. Check scan. What are the force acting on the beam? Mg acting down here. 300 acting up here. That's all. No other force. Of course, there is a force acting on the pivot. I told you this many times. Pivot will have a force. But that unknown force, you no need to care because we're taking moment about pivot. So that force will disappear. Won't form in the equation. So mg gives a what moment? Clockwise moment. 300 give a anti-clockwise moment. So should be balanced, right? So moment, what is the moment caused by weight? Mg times perpendicular distance. What's the perpendicular distance? Entire thing is 2.5. This is 0.5. So 2.5 divided by 2, right? 1.25. So weight is times 1.25 distance from the pivot equals to 300 times how far away? 2.5 minus 0.5 is 2. So from here you can work out the mg. So what is your m? This is rearranging right after that. So 300 times 2 over 9.81 times 1.25. So this is your mass in kilogram. Okay, calculate what you get. 49. So you get A. Answer given A.
The answer is C.
Answer is given is C. Oh, 20 is C. Oh, cannot be C. C.
Shouldn't
Yeah.
it be mg times 1.5 now 1.25?
Mg times 1.25.
Because the bar is 3 meters.
Bar is 3 meter.
I know, right? I'm right.
1.25, right? Yeah, 1.25. 353 kilogram times 9.81, quite huge. No, I think there is a mistake in mark scheme. Cannot be. So cannot be, because weight times 1.25 should be equals to 300 times 2. This for sure. So I think there is a mistake in the answer. Should be A. 49 times 9 point, yeah, 300, 10, 600 divided by 10. Yeah, should be A. Should be A. Okay, Ashley, you got idea, huh? Should be A, cannot be C. Doesn't make sense. Okay. Yeah, some trial papers, some mark scheme might be wrong slightly, 1 or 2. So yeah. So any part don't understand from this 20? The answer change, should be A. Any other questions?
21.
21. Or deformation of solid. Okay. So 0.8 meter length of steel wire. Steel wire is 0.8 meter and 1.4 meter. Brass is 1.4 meter. Are joined together. The combined wires are suspended from a fixed support from force 40 Newton. Okay. The Young modulus of both material was given. Each wire has a cross-sectional area. Area given, Young modulus given. The wire obeys Hooke's law. Okay. What is the total extension? They're asking for the extension. Ignore the weight of the wire. So they want extension, total extension. So total extension means you need to find the extension of the steel plus the extension of the brass should be the total extension. Okay. So we need to find what is the extension of the steel and brass. Okay, how to find extension? So because Young modulus is given, so we go for Young modulus formula. Young modulus is what? Force over area, extension, original length, right? Okay. So for the case of steel, the extension is steel. Take the extension of steel as the subject. Force L0 EA. Okay. Do you know these 4 values? Force, do you know? Force is 40 Newton, right? You have to know that, because these two are in series. You see, 2 spring in series. I told you many times. If you have 2 spring in series, do they help each other to support the load? No, right? You're not helping support. The 2 springs never help to support the load. They're not really sharing the weight. Actually, this is equal to the each spring carrying the load separately. They're not helping each other. That means the force on steel is 40 Newton. So it's still 40. The original length we know 0.8. The Young modulus for the steel, do you know? Young modulus is 2 times 10 power of 11. And the area, do you know? Area also know what? Each wire has area. So 2.4 times 10 power negative 6. So you can find the extension of the steel. So you can do the same thing for the brass, right? You can do for the brass also, you can do the same thing. You know the force 40, you know the length is 1.4. The Young modulus for brass is what? 1 times 10 power of 11. And what else? What else? Area also the same, right? 2.4 times 10 power negative 6. Yes, correct. So you find the both extension. Make sure all the units are SI. Is it any all SI? Meter, all SI. Length is SI. So all SI. So your final answer will be in meter. Add these two. This two, both extension add up is the total extension. Calculate for me. Give a try. These two. What do you get? Give you a minute. So calculate these two extension. Add them. What is the answer you get? 1 minute for you. So do you get the answer? Actually, which part you don't understand? So do you get the idea?
Yeah, because at first I added the two together, the Young modulus.
Oh, okay, no. Because they are separate materials, so separately you have to deal. Okay. Okay, so any part still anyone don't understand this question? Hope you got the idea. Okay, any other questions from this paper? Anybody?
24.
24. Okay, so 24 is the stationary wave. Okay, what do you want? A long tube filled with water as a tap fitted at its base as shown. The tuning fork is sounded above the tube and the water is allowed to run gradually out of the tube. Oh, okay. So the water level is dropping. Okay. So a louder sound is heard at intervals as the water runs out of the tube. The change in water level between the louder sounds is 32 cm. Oh, this is the key point. The change in the water level. The differences between two loud sound, the length is 32 cm. Okay. So what was the wavelength of sound table? Okay, so now you see, this is sound stationary wave. You get, if you remember when we discussed, we got open pipe. We had one end closed pipe, one end closed pipe like this. Okay, so this is actually open pipe or closed pipe. The type of what do you call stationary wave form? It's a closed pipe. It's one end is closed. This one end closed. Okay, so you blow from top, the sound go and hit the basement and come back. So it's a closed pipe. So closed pipe, do you still remember the pattern of a stationary wave? The first pattern will be like this, right? First pattern will be like this. You get the loud sound, right? So that means from the top. So when the wave produce a nice shape like this, which is how many wavelength is this? The length here, the length we don't know. How many wavelength? Like a quarter wavelength, right? And the length of the tube is like a quarter wavelength of the wave. You get a loud sound. Okay, first loud sound. Okay, L. They didn't tell what is the L stands for. Then, when the water level go further down, then this following pattern will happen. Following pattern. You get a loud sound again. When it's able to form another half wavelength, you get loud sound again. The following pattern. If you still remember, go and check the notes. The following pattern is like this, right? How many wavelength is this? This is half. This is quarter. 3/4 wavelength. So the new length, which also not given to us, the L2 not given to us, it should be 3/4 wavelength will give you a loud sound again. So this 32 centimeters actually what? This 32 centimeter is the change water level change. The change means what? This is L1, L2. Change means what? The L2 minus L1 is 32 centimeter. This is what you should predict. The L2 minus L1 is 32 centimeter. So L2 minus L1 is 32 centimeter. So 32 centimeter, how many wavelength? L2 is 3/4 lambda. L1 is quarter lambda. So L2 minus L1 is actually half lambda. Half lambda is 32 centimeter. So lambda should be what? 64 cm. C is answer. Okay. Okay, guys, got the idea? Okay. Anyone, any part don't understand? Actually, you got the idea. Which part you still don't understand?
Sir, can you explain how you got L1 and L2?
Because you see, here is the wavelength of the sound changing or not? Is the wavelength of the sound changing or not? Doesn't change, right? Because you are using the same tuning fork now. Because we are using the same tuning fork, the tuning fork going to give us certain frequency stated on the tuning fork. If it stated like 500 hertz on the every tuning fork will have stated how much is the frequency you can produce. If it's 500 hertz, it's going to produce a sound of 500 hertz of frequency. So the wavelength of the sound doesn't change. The wavelength is constant for the sound, okay, produced by this particular tuning fork. So when the water level goes down, we know that the sound have to go to the basement, reflected back at only a specific length. The quarter wavelength can happen. A quarter wavelength and 3/4 wavelength. Okay, when the length become quarter wavelength, the loud sound will appear. The loud sound will appear. Stationary form, a stationary wave is formed at quarter wavelength. Okay. So when the water level goes down, you don't heard any loud sound. Suddenly, when you reach quarter wavelength, suddenly you get a loud sound. You'll have a loud sound. That means stationary waves form. That means we understood that quarter wavelength, the vertical length is actually equal to the quarter of the wavelength. That's what has been discovered by scientists. The first loud sound in a close by happens when the vertical length is exactly quarter wavelength. Then you will get a loud sound. Okay. Then when you go lower, you won't listen any loud sound. And the water drain out until it becomes just nice to make a 3/4 wavelength. You will get again a loud sound. Okay. So the loud sound for close pipe appears in which type of wavelengths, which type the length should be how many wavelength? You learned that in your notes, right? Last time. Hold on. Yeah. So go back, check in the close pipe. Close pipe, this is the pattern. So the length is quarter wavelength, you get a loud sound. Okay. Okay. When it's like the length is 3/4 wavelength, you got a loud sound. And so on. The length is adding another half 3 lambda or 4, adding another half wavelength. You get a loud sound. It's going to be 5. How much? 1/5/4. Yeah, 5/4 lambda. Yeah. Pattern is like this. Okay. The closed edge always form a node. The open edge always form a antinode. Okay, to get a loud sound. So from here, the first loud sound is quarter lambda. The second, the following loud sound, definitely 3/4 lambda. So according to this question, a louder sound is heard intervals as the water runs out of the tube. The changes in the water level between the two loud sound, okay, two consecutive loud sound is 32 centimeter. This is exactly same as half wavelength. Okay, every half wavelength you'll get the loud sound. So the differences of the wavelength is half wavelength. So 32 centimeter is actually half wavelength. So what is the wavelength of the sound? Just times 2, 64 cm. Okay, so this is what Okay, any part still don't understand? Riyad? Okay.
Thanks, sir. Yeah, I understand.
Actually, you got the idea?
Yes.
Okay, the others, any part you still don't understand about this question? Okay, so I assume so everyone can understand. If any questions, you can ask me now. I can explain further. Don't have, then I assume you got the idea. Okay, any other questions, guys?
25, 26.
Okay, 25. Okay, 25. What is the order of magnitude of the frequency of electromagnetic wave in the visible spectrum? This you have to know the you have to know the it's a fact to remember, right? So what is the range of the the wavelength one? Wavelength. You remember the wavelength is okay. What is the wavelength of the visible range? Red to violet. Okay, red is how much? 400 nanometer, right? Violet is 700 nanometer. What I'm doing. The other way around. Red is 700 nanometer, violet is 400 nanometer. So it's 7 times 10 power negative 7 meter. This is 4 times 10 power negative 7 meter. Can you find frequency? Frequency is what? V over lambda. V is speed of light, 3 times 10 power of 8. So put one of the wavelength, 7 times 10 power negative 7. How much the frequency get? 3 times 10 power 8 divided by 7 times 10 power negative 7. What is the order of magnitude of frequency electromagnetic wave in the visible spectrum? Oh my God, I think there is a mistake also. Oh, okay. I think this is not 1010. This is 10 to the power of 10, 10 to the power of 12, 10 to the power of 14, 10 to the power of 16. Okay, I think it's actually the power. That's 2 digits at the back is the power. So what is the answer then? This is going to be what power? 3 over 7 times 10 to the power of 8 plus 7 is how much? It's 15. So 3.7 is 10 power of 16. So should be D is the answer. 10 power of 16. Sorry, it's not 1000. So 10 power of 16. So it should be D. Okay. Yeah, there is a mistake in in typing. It's power at the back. So actually got the idea.
Answer is C.
We give 10 power of 14. 3 times 10 power of 8 divided by 7 times 10. Oh, if we go for 4, 3 times 10 power of 8 divided by 4 times 10 power of negative 7, you get 0.75, still the same, but 0.75 times 8 plus 7 is how much? 15. So you make it as a scientific notation, scientific form, standard form is 7.5 times. Oh yeah, sorry. Movia is 10 power of 14, right? Yeah, correct. C, sorry. C. Minus 1, 15 minus 1. Yeah, C. Okay, Ashley. Maths error. You got the idea?
Yeah.
Okay. Okay, next 26. Okay, look at 26. Okay, the others, you have any question, just tell me, so we can discuss. Okay, 26. A toy motorboat moving with a constant velocity v vibrates up and down on a surface of a pond. This caused the boat to act as a source of circular water waves. This causes the boat to act as a source of circular water wave of frequency of 2 Hertz. Okay. Okay. The speed of the wave is 1.5 meter per second. A man standing at the edge of the pond observed that the waves from the boat approaches him with a frequency of 3 Hertz. Okay. The formula for Doppler effect calculation with sound wave may also be used for water wave. What is the possible value of V? So this is a Doppler effect, right? Okay. Do here. Okay, so the motorboard is like, can consider as the source. Okay, it give out a wave, and the side the person is standing is the observer. So they're asking what is the speed? What is the speed of the motorboat? Is the motorboat moving towards the person or moving away from the person? This is the Doppler effect, right? The frequency of the observer should be what? Speed V plus minus, right? Plus minus with the V of the source times the frequency of the source, right? Correct? Okay. The frequency sensed by the observer is increasing. The observer has increased, frequency has been increased. That means definitely the board is approaching him, right? So answer must be towards the man. Answer must be B or D. Because you see 2 hertz become 3 hertz. The source produced 2 hertz, but the person sends 3 hertz. That means observed frequency is 3 hertz. So the source is 2 hertz. So the source is actually approaching the observer. Only approach frequency will rise, right? Okay, when the ambulance approaching you, get a higher frequency, right? So the boat definitely approaching the man. So answer is B or towards the man lah, B or D. But is it 0.5, 0.75? You have no need to add at the bottom or minus at the bottom. So what do you have to do? F naught V B of these two are V of the sound, right? Speed of sound, speed of the wave lah, actually in this case wave, the water wave. Plus or minus at the bottom. Should be minus, right? Minus the Vs, speed of the source, Fs. Yeah. So this is 2 hertz. So what we are looking for? We're looking for the speed of the board, right? Speed of the board. Sound wave may be also be used for the water wave. What is the possible value of V? The speed of the wave is 1.5. So we want the speed of the board lah. Yeah. So speed of the board. We are looking for the V of the board. This is the board lah. The source is the board one. So this is the speed of the water wave. Water wave. What is the speed? Water wave speed is water wave how much? 1.5. It's 1.5. So put here 1.5, 1.5. This is 2, 3. What I'm doing, this is 2. The source is 2. The observer is 3. So find the speed of the board. Okay, what do you get? So whatever answer you get is the answer. Okay, Ashley, which part you don't understand? Is it okay?
Okay.
Okay, the others, any part you don't understand about the Doppler, when something getting closer, the source getting closer, then the frequency rises. So it's definitely get closer. So therefore down is minus. Okay, so last question, maybe any other questions? Okay, guys. So we will discuss the next class. Okay. Tomorrow we again go back to A2. Okay, so next Wednesday we'll be discussing this paper again. As usual, go ahead, explore the questions. The more you explore, the more you prepare for your trial. Okay, the more you prepare for the trial. So let's see how many of you can reach the entire paper. It's quite a long journey. Okay, so more you do, more you prepare. But As long as you stabilize with the mark of paper 1, 33, paper 2, 45 out of 60. Okay, that means you have enough papers. You've done enough papers, but you need to stabilize the marks. Those who get less than that value, you have to do more. Do more until you stabilize with that 2 scores. Okay, so see you then. I stop here. So see you back tomorrow. Any questions? No questions. Yes. Okay, thanks.
Thanks, sir.
Thanks.